Best way to use endpoints. So we're going to talk a lot about snaps. So it may be old news if you have already seen my videos, the very first Design Edge learning series, because anytime you click or choose a location in Design Edge for whether it's the beginning of a line, the end of a line, the placement of a circle, it has to go somewhere with precision. So with artwork, that really doesn't matter unless you are trying to draw a continuous path. So to answer the question specifically, when I do a trace, let's just switch over since it's about time. Anyway. Okay, so hopefully you can see my screen. If you can't tell me, according to this fancy app, it says you can. So let me just go to, open a new window here so I can drag it over. So if I want to trace an image in Design Edge, let's say I want a deer silhouette. It's about 6,000 times what is traced. So we'll just get a picture and we'll save it. And then with Advanced Design, we'll import it. And when you pull that picture in, it's going to give you some options up at the top. So if you wanted to do an automatic trace of this, to have Design Edge trace it for you as best it can, you would check the Convert Image to Vectors. A lot of times, though, we get images that either aren't good for an auto trace, they're an actual photograph, or they are just too blurry to get a good trace. This one would probably come out okay, but for the purpose of showing you, I'm not going to. So I'm going to leave it as just this top one, just the top checkbox, which is Show Image in Drawing. And that is an advanced design feature. So if you don't have advanced design, it will not show it to you in the drawing, and your only option is to have it convert that to vectors for you. When you pull it in, if you look down here at this image size box, you'll see that it asks you for a few different things. You can set the resolution, or more importantly, maybe it's telling you what the resolution is. If you make a change to one of those boxes, it's going to adjust the others because the aspect ratio is locked and there's only so many pixels in this picture that we got. And so if I wanted, you see there's a banner at the bottom, so I'm going to ignore that. But so from the right side to the left side, if I wanted that to be about 18 inches, I would just type 18 in the width, and then it's going to automatically scale the height and tell me that since I increased the size, there's less dots per inch, but the top box doesn't really matter. So I'll push next, and then now I just have the picture in my drawing, and you can use F11 to toggle that on and off. So you can see that now I've just got the picture. So the best tool that I have personally found for tracing is the Bulge tool. And when you do that, it's going to, it's Z. But when you use that tool, I'm going to turn the picture off for a second. It asks in the bottom corner for a start point and an end point. And then after that, you pick a point on that arc. So you can adjust the radius of that arc. And so that's nice to go around the perimeter or the details in a drawing. So let me turn that back on. And I'm going to use F1 to zoom in, F2 to zoom out. F1 zooms into wherever your mouse cursor is. So it's kind of all a fluid thing for me. So I'm not going to tell you every time I push F1 or F2 because I'm going to move the cursor down here by this bottom left corner, and I'm going to push F1 a few times to zoom in. So now I can see in close to that hoof and get started. So I will push Z for bulge, and then I'm just going to start something down here at this corner. And you're going to go up just about as far as you see the radius is continual. It's kind of something that you pick up as you go along. And I'm going to drop that in. So I'm going to zoom in a little bit so you can see what I'm doing. I'm going to drop that line right there. About the left click. Now, the question Chris had was, when am I going to use the snap? So all I have now is a little line. So I want to keep going. So I'm going to turn my picture back on. I'm going to Z for a bulge. For the beginning of this bulge, I'm going to push E. And you're going to see the little snap indicator come on as an E endpoint snap. And then I'm going to click on that line I just drew. And let me turn the picture off. What that did is it snapped the beginning of my next bulge at the end point of my previous. So F11, I'm going to bring it back on, and I'm just going to work my way up to this corner. Then I'm going to Z, E. I put my pinky on the Z, my ring finger on E, and go and go and go. So as I come up here, I'll come up along it. I can push F11 and turn it off and see what I'm doing. Z, E. Now see, I see it comes up and then starts to break the other direction. So I'll just go up to about where it starts to turn. Z, E. You can always turn that picture back off and find it. Z, E, and work your way around. So again, Z for bulge, E for endpoint snap. All I have to do is click close to the end of my previous bulge. If you miss, just hit right click or escape and get back on it. F11. So you can come right around this, trace your whole deer. When you get done, you're gonna come all the way back around the deer. You'll have a series of lines, and you'll just hit J for join, and you'll have them all together. So that's how I use the bulge and the endpoint snaps to work my way around. Let's see, what do I look for when tracing something for plasma cutting? Well, typically it's what my customer wants. What I try to look for is somebody that is not trying to draw the Eiffel Tower on a bar napkin with the blunt end of a crayon. So what I mean by that is it seems that everybody wants to cut as detailed as they can, as small as they can at the same time. And so you have to remember that for our plasma cutting, the kerf is, around 30 to 60 thousandths of an inch. And so you need to be mindful of what material you have available and how it's going to cut. So if you don't leave, if I have a detail that is if I'm going to cut this shape out in plasma, I need to pay attention to how much left material I have right here, because it's going to burn up if it gets too small. So when you bridge and stencil your letters in, when you put pieces together, to say that I design it mindful of plasma cutting means that I pay attention to the thickness of the bridge that's left, and assuming my kerf setting is correct, when I use my offset, as long as you leave 0.15, if you have a 0.15 bar in most material, it will not burn up and fall away. The other thing to look for that's kind of a handy thing is when you are trying to figure out where the torch can cut and what it can get into, you can zoom in and you can use the circle tool, which is Q, and draw that the size of your torch curve. So if that's 35 thousandths, then put 0.035, enter, and when you move your mouse around, you're going to be dragging a circle that's the size of your torch curve. And so you can see that this is a sharp corner that's drawn, but the torch is only going to be able to go that far. And so that matters a lot when you get into fine detail and you're trying to determine just how much detail you can put in to a drawing versus what your torch is actually capable of. So what is Control M? I don't even know. Spline? No, I don't use Spline. It's probably because I'm not smart enough. So if I wanted to trace this with a spline, then in a spline, you're defining a frame. So I would click here, maybe, and here, and it drags off. That doesn't, I don't know how you trace with that. Somebody better than me probably can. But you build this frame, and so you're not really following anything. You're drawing a frame that holds the arcs of the spline together, and I don't have any idea how to use that, because even then when you right click in the end, it even still yet moves. So it would be okay if you were using it to draw abstract shapes and you were making something and not necessarily tracing something. But for me personally, it doesn't work for tracing. So I'm not sure how you would go about using that to trace. Let's see. Seriously, use the spline tool to trace all of that? Well, I hope you come to Tulsa and teach me how to use it, because that's not anything I've ever been able to do. I can fly through with the bulge and the endpoint snap and get right along. Let me pull up. I want to show you Paint.net is what I use. It's a free raster image program. And, well, welcome. We'll see you in Tulsa too. I use Paint.net to clean up and prepare images for tracing, even if I'm doing a manual trace. It's free. Websites getpaint.net. If you have Photoshop or something Corel, then keep on, because that's what you're used to. But for me, this is what I use. So I'm going to show you on that deer picture one of the things that I would do if I were actually going to trace it. I would come in and first I would crop off the bottom, because that doesn't apply. And then this is pretty clean, but I would, if I were manually tracing this in Design Edge, the big problem is we draw on a black background. And so open paths are white. And so when you draw and you don't get on the black part of your drawing, you can't see your line. So what I do is, if I've got a black and white picture, I will invert the colors in Paint.net and save it. That way, when you pull that into designs, you can do it if it's not black and white. If you have a light background versus a dark foreground, you can do that too. And then when you pull that in, now you wind up with a white drawing to trace and your black background. And when you start with your Z bulge or your spline, if you're better than me, now you can see that. and it's a lot easier to get that E endpoint snap on it. I can see what I'm doing a little better. So let's see. Another tool that you can use is the T, which is trace. If you use a touch screen, it's a little tricky, or if you use a digital tablet that mimics a mouse, you can get pretty good results with that. But if you turn your T-trace, I use a trackball, and it gives me a decent amount of control, but you can come in and trace that manually and work as slowly as you can up, and you wind up with that. And it looks terrible, but it's really not. You can now come in and use the smooth tool after you get that drawn, which is H. And after you have that basic shape in, you can come in and use H. On a drawing this size, you use a small margin like 0.005 and hit enter and look. So it's still jagged. So I'd probably page up and I'd H, and I'd go to a bigger margin, 0.009. And that's coming better, and you could probably go 0.011, and that would cut just fine. So trace gets you a good beginning, but you will have to go back in and clean it up, and it will cause you a lot of overlaps and loops and intersections that you may have to come in and clean up. So let's see, have I missed a question, or are y'all just quiet? Let's see. What else have you been fighting? Let me see. I'm going to we're focused on drawing, and that was really my plan to go at today. But let me take a quick detour, and then I'll sure come back to that, and we'll look at some files that I've done, and the other. But let me quickly give you a rundown of starting your cuts for the day, and anybody that's talked to me any length of time before today knows that I've probably drilled this, every time we've talked. But if you have a good cutter, Hypertherm being one of them, some of the others have some good book numbers, you're going to go set the four main parameters before you start cutting, and that is going to be, if you have advanced height control, it's going to be your pierce height and your cut height, which are here and here, and it's going to be your cut speed and your time to pierce that path. So those settings, those four, are going to come from your book. You're going to set those very first thing you do for the material you're using, the consumables you have installed in your torch, and the amperage that your machine is set at, and that should all come directly from the manual. So if it's a Hypertherm, it'll come from the cut charts in your Hypertherm manual. After you set those, draw yourself, and I'm talking about advanced height. There are some, if you have basic, there's still part of this applies. Draw yourself at least a 6-inch straight line in the scrap area of your material, convert it to a cut path. Right before you do anything for the day, you open it and you're going to check both of these boxes for auto 0 Z shift and auto 0 arc voltage shift. Those are going to calibrate the machine so that you'll have the best possible height control once you start cutting your design. If you do it as a part of your design on your first cut's usually very short, and rarely is it straight. And so you usually wind up, if you try to auto 0 on that first cut, you wind up with an incorrect, or at least not as accurate as it could be, arc voltage shift. So I always want to recommend switching over and using just a straight line, at least 6 inches long to start with. Check those boxes. They won't be grayed out on yours. This is just a design computer, but if yours is connected to the table, you'll have those boxes. You check them, you click OK, and you cut that straight line. And at that point, you reopen your setting window, you make sure both of those boxes cleared, and then you, as long as the straight line cut was good quality, cut your design and go to work. So, okay, I did not talk about centering, so let me back up to that. Centering is, and aligning things to each other, is a function that I desperately wish they would add, but right now there's nothing. Let's see. Let me pull in. There's one I was tracing. So I had to take these pieces and center them. And so let's say that's off out in the middle of the wind. There is, you know, in Corel and other programs, I could select all of this and group it. And this and group it, and then I could click this and click this, and there's a button that would just let everything center up. There's no such thing here. So the best way that I have found is to use some reference lines. Not every line you draw, you know, has to stay and be a part of your final drawing. I use a lot of reference lines to move things around, because sometimes the visual center is, I'm hoping your screen improves. I'm still on Hooterville Internet, and so hopefully that improves. Let's see. So if I draw this reference line and I have this circle and I want to center this text up to this design, I'm going to use some snaps to move that line to be in the center. So I'm going to F1 to zoom into my mouse cursor, and I'm going to look at it. So the top of this is a circle or an arc. So it has a quadrant. So watch my video on snaps if you haven't already. It's the Design Edge Learning Series #1. But I'm going to use the snap for quadrant to get this center line over here to the middle exactly. So I'm going to M for move, and then I'm going to H for an on the path snap, and that's going to grab that line right on the path. Good deal. And I'm going to use Q, which is the quadrant snap, and then if I snap on that arc, it will snap to that quadrant. The quadrants are being at 12 o'clock, 3 o'clock, 6 o'clock, and 9 of a circle. So now this line will be center line of my design. And now to move this, there is no center. And if you're familiar with the measure tool in Design Edge, what it gives you is not the distance, not the measured center. It is what's called center of mass. So if I push F8, it's going to open up this window and tell me what I have selected. But it's going to create this little red spot. And the little red spot is center of mass, not center of anything else. So since that star is more solid and off to the left, the center is over here on the left side. So for me, as accurate as I need to get this in the middle, I'm just going to draw a line. So I pushed L for line. I'm going to draw a line from this edge point over this approximate edge over here across, and I'm going to push O for orthogonal snap, and that's going to keep my line perfectly horizontal, and I'm going to eyeball about where the edge of that is. And so now I can grab all of this, and I can use my M move command, and I can zoom in here, and I can use my M midpoint snap. And if I click on that line I drew, it will grab it by the very center. Now I can do one of two things, and I want to show you, I could just come down here and use an H on the path snap, but sometimes when I'm in tight and in close, I just want to move it straight over. And so I don't want to move it up and down, only straight over. And so this is a good opportunity to tuck the trick of using the perpendicular snap back in your mind. So if I wanted to move that piece of text straight over to this line that I drew, I would use P for the perpendicular snap. And then if I click anywhere on that line, it moves it straight over from where it was. So you can use those snaps in the move command a lot of different ways to get that result. And then now I would just move it down where I want it to be. And so I would use M to move, and the first place I have to click is anywhere I want. And then I would just push O for orthogonal so that I could drag it straight down and put it on top, and then I could delete my pieces. So that would be true if I had multiple circles and I wanted them all lined up centered. I could quickly move those into a line vertically by moving with a C center snap to a P perpendicular. Same way, select that, M move, C center snap, P perpendicular, M move, C center snap, P perpendicular. So I could get them in line that way. And then, I mean, you know, there's also another one of the tools that can be found in Corel is distribute, or in VSR, in the Vinyl Master program I use. So it's really nice because I can tell it to evenly distribute them. I don't really use it as much in plasma cutting, but let's say, for instance, I wanted these circles to be perfectly straight up and down, but 1 inch apart. So, I mean, there's a way to do that. I would just M move Q quadrant to Q quadrant, and that would put them right together. And then for the next entry, you can just use a coordinate move. So I can do M for move. It's selected. Click anywhere I want. And if you've been to my class, you know that I'll teach you about the differences for entering coordinates, or you may have found that on your own. But you can either enter an actual coordinate, which is from the 0, 0 corner of your drawing, or you can do what's called a relative coordinate, which is in reference to the first place you clicked. So if I wanted to move that circle down 1 inch away from its neighbor, then my move to point would be at, so shift and the number 2 for the at sign. And then I would push nothing side to side, so 0 in the x-axis, comma, -1 to go down, and enter. And that'll put those circles 1 inch apart. So I can distribute things that way. And I mean, honestly, that's what I do. I trace this drawing as well. And so I drew this text in, and it wasn't spaced right. And so I just did orthogonal moves until I got it exactly like I wanted, and I got the spacing. And then I would unselect the letter. So you can work with it and get it that way too. To get a face or vehicle photo to vector, well, that requires a little artistic interpretation usually. So let me just import one that I just did. And I'll take you through one real quick. It was a small little deal, and we needed it to be about 12 wide. And I know there's some stuff at the beginning and the end of that car, so I imported it at 13. So there's my picture that I had to turn into a car. He wanted to cut it 12 inches wide. And so there's no possible way we're going to draw all of these zigzags in here. So you've kind of got a little responsibility to do some artistic interpretation to know what will fit, what'll cut, and what won't at that size. If I cut this at 4 feet, I could get all of those details in there. And he wanted a single layer. He didn't want it multiple layers. So let me see if I can pull in what I actually did, maybe. And with any luck, oh good, it's the same size. So here's what I manually drew. And I bring this in so you can see for the wheels on the car, I just looked up. I think this is some kind of a Chevy car. I just kind of looked that I recognized, so I recognized the wheels. This has the factory wheels, looks like a wreck 'em up derby car. But I just looked at what those wheels looked like and kind of made them. Here you can see I kind of fudged where the holes in the bumpers are to get my spacing right, because remember, it's important that we have enough material left, and I went this down to 1/8 of an inch. And then the license plate is not really in exactly the same spot. The net in the window is nothing like the original, but it's close enough that it mimics the piece. I got the number 11 on there, and then of course I added some effects. So that's the cut piece that I wound up with for the car. As far as the best practice, I mean, you just have to look and see what the size will allow. So that's only 1/4 of an inch wide. So if we're cutting this out of 14 gauge material, that's going to be enough to hold up and hold together. But there's no way I could draw all that fancy little zigzag in. I needed to capture the spirit of the car so that it would be unique to the owner. They would recognize it easily, but not have it be a wadded up piece of cuts that was going to fall apart. Let's see. So how do you connect two objects together? What kind of objects? There's a lot of objects we can do. If I wanted to take a rectangle, I'm not going to regret pushing text. I have way too many fonts and it takes a minute to load. I'll show you a couple of things about tying text in, and we'll see what we can do from there. So if I want to connect this line of text to this bar, there are a couple of ways. Since they're all open paths, there's a fast way with advanced design, and that is to use the combine tool. And it only works if there is nothing boxed in, if it's very clear what you want to combine. So if I push combine, you can see that that welds everything right together. So let me undo that. And let's say you need to do that manually. You would use the X tool to trim that out where they overlapped. So I could use X and I could trim all of those pieces in the middle. And a trick about this X tool, so as you can see, I trimmed that corner off, but it hit something right here. And so it stopped. So I could go in and I could use it. I could click X, 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 X and get all that out of there. Or I can trim one end of it off. And if you hold Control down, if you look in the bottom corner, it's asking for instructions. It says pick path to trim or extend and use Control to force it. Force it means either to extend it, even though there's nothing for it to hit, to the edge of the screen, the viewing screen, or to delete the rest of the path no matter whether it hits something or not. So I hold down Control and I click just to this side and it trims off the rest of that path. Now I can just one click and trim that out. So that's kind of the trick with the trim and extend tool. Once you have that trimmed out, it's a white path and it's open. So to make it cut well, you're going to have to link that back together or join it as I. So you're going to push J for join, or go up to edit, or wherever it's at. I don't ever use these menus. Yeah, link right there to put it back together. So if that answers your question about joining, then good. If not, let me know something maybe more specific. If I had this like this, and I wanted to, you're welcome. If I wanted to join this, then I would have a little more of a challenge. And that would be because now if I use the combine tool, it has no idea what I want it to do. So it just deletes it all out. It combines it, and everything that's a hole in here becomes gone. That's not what we want. So if I had a whole bunch of text to do, or a long list of things, I would come in here and I would break this out. You can use the X trim tool, like I said earlier, and put that together. So since there's not much here, with a few clicks, you can be right there together. So that was X trim for all of the paths where they overlapped, and then J for join. If it was a very long process, then what I would personally do is I would come in here and I would break with the K tool these pieces where they touch, and I would come in here and I would select them. I'd leave those bits, and I would move that out here. And then I would get my L line tool, and I would draw, and I use the E endpoint snap to grab that endpoint, and I would just come up here out of the way, and I would E endpoint back to here. And I'm going to right click, I'm going to L line, E endpoint, same way down here. And all I'm doing is making some closed paths above and below. Now they're not, now it's not a hole out in the middle of the piece. I can select it all. I can push Control B, so, except that I apparently did that before I had resized that, so I will fix it. Okay, Control B, that's going to join everything up together to those lines. And again, I wouldn't do this if I just had a few pieces, but if I had a whole bunch of letters to tie in, this is what I would do. Then I would K break it at N node point. And since this is a line, as long as I click on this line close to that corner, it breaks it at those node points. So I did an N node point snap at each spot. I delete that off. I select all this. I move it, E endpoint. So I grabbed it by that endpoint, and I take it over here and I snap it back to this E endpoint. Don't have centers, they have midpoints. So if I wanted to draw, or let's say I wanted to draw this or move this square into the center of this circle, the first thing I have to do is pick where I want to move from, and then where I want to move to. So in order to move it, I would M for the move tool, and then I would C for center snap. And here's where the confusion comes. C for center snap does not mean click and give me your best guess where you think the center of the square is. It means tell me what shape it is that you want me to snap to the center of. So for the program, for a mathematical CAD program to understand that, you want to click right on that line. So on the actual path. And when you do, it will jump to and grab it by the center. And then to put it in the center of this circle, I would use the C-center snap, and I would click my crosshair right there on the path of the circle. And that's what's going to jump it to the middle. So, oh dear, is my internet dying? Hopefully it will record well enough that if the quality goes down, we can always come back to it later. So, okay, so let's back up. How can you create cut paths for a full sheet of parts with one step? Sometimes you can and sometimes you can't. It's not, the best way is to cut paths, make your cut paths, and then array and nest your parts. If you have their nesting software, I think it works that way. So here's hoping. I don't have it yet. I bought it before they had an integrated nesting, and it didn't work very well, but that's the one that I bought when they had it. So if you have a full sheet of parts, let me see. You have a full sheet of parts. Let me just pull in some plain old parts. Good. So here's a whole bunch of parts. There's a whole bunch of dimensions that I forgot I left on. Let me pull some of those off. So the best way, if I had repetitive, as you can see, I needed, oh, good. So if I need 6 of these and 8 of these. I would personally come in here and maybe array these and get myself 6 of them. And then convert them, or you can come in here and make your cut path first. And then when you do that and array it, you'll have your cut paths. And then to do the full sheet, you just pick what you want to cut and cut. I don't know that there's a great easy way to have a whole bunch of closed paths and have it automatically do them, because anytime you have an island, if I had these parts out in my sheet here, and I wanted to convert those, the problem is it's going to think those are holes, and the little actual holes are going to be islands that don't convert at all. So there's no good way to convert the entire sheet without clicking each one individually or converting them before you copy them or array them or duplicate them. So if you have a design that you want to cut a bunch of holes, say a design out of a solid piece, but you don't want to cut the perimeter, you can draw a big rectangle around it all and convert the perimeter. Like if I wanted to cut those holes out of a piece of plate, but I don't want to cut the perimeter of the plate, then I would simply tell it to convert the whole big thing and yes, do the holes, and then I can just get rid of those perimeters, and I'll have the hole to cut holes, but not to cut a whole bunch of parts. So maybe that answers that. Okay, Ron, 2 circles. One is 1 inch, the other is 2 inch. 6 inches center to center. Attach the outsides, make a big oval. That I'm going to say probably is going to be looking like a little belt guard, maybe, in my mind. So if I want a let's see, you've got two circles. One's an inch, the other's 2. So first thing I'm going to do is draw, cue a circle, 1, which is going to tell it that I wanted a 1-inch diameter, and hit enter. And there's my 1-inch circle. And then I need a 2-inch circle. So I'm going to push Q, 2 for a 2-inch circle, enter, and now I have it to drag it around. Now I can get those center to center distances one of about 15 different ways, but for the purposes of showing you the way to do it with the least number of clicks, first I'm going to use a C center snap, and since anytime you draw a circle, it automatically draws it from the center. So it's asking me, where do I put the center of this 2-inch circle? And I'm going to use the C center snap and tell it to put it at the center of my 1-inch circle. Now you want it to be 6 inches center to center. So all I'm going to do is move that circle. So I'm going to M move, and I'm going to click one time, doesn't matter where, because I'm going to use the @ sign, which is in reference to my very first click, move it this way. And so it needs a coordinate X, Y. So I'm going to move it X sideways to the right 6 inches, comma, 0, because I'm going to have it not go up and down at all, enter. And so now there we have a 1-inch circle and a 2-inch circle with 6 inches on center. And I can show you that like that. So there's our 6-inch on center. Now, there are other ways to do that. We could use a grid snap. I could move the C center of this circle to a G grid snap. And then I could have drawn this or move it, and I could count 1, 2, 3, 4, 5, 6. Turn on my grid snap again. And there's my 6 inches on center. Another way is if I need it to be at an angle, then I could draw a line from the C center of this circle. I'm going to do something here I shouldn't. But there's a 6-inch line at a 30-degree angle. And if I do a dimension, then you can see I've drawn a 6-inch line, and I can move it from the C center to this E endpoint. So there's your several ways to get your circles 6 inches apart. But let's get back to what we're drawing. So we got 6 inches center to center, attach the outsides to make a big oval. So what you're looking for here is called a tangent snap, and that is to have it just touching the arc of the circle, but not crossing it. So to connect those, I would do L for line. You can also bring up the snap menu by pushing the center mouse button, and that's going to show you all the snaps that you have available. I have them all memorized, or use one of my little mouse pads for a quick glance, but tangent snap is where you're headed. You click T. You're going to have to use this at both ends of this line. And so I'm going to click on the path of this circle with the T snap. Don't pay any attention to where it snaps the first time, because it's going to be relative to where we snap to the next one. And I'm going to use the T snap again over here, and watch what happens when I click on that circle. So that jumps right to the outside so that it's just touching each of those circles. And I'll just repeat that process for the other side. So L line, T tangent here, T tangent here, and then X trim. And I will trim out those pieces, right click, J to join. So I think that's what you're after. And let me show you now, Control D for dimension, C center. I can still find the center of that partial circle. It's an arc and still has a center, same way over here. So you can see that I'm 6 inches center to center. How do I cut dimensionally correct parts? Well, you draw them dimensionally correct, and then you accurately set your kerf. Remember too that your kerf changes based on the material that you're cutting. This happens to be a cut chart for a Hypertherm 45XP low-speed fine cut. On the larger and older Hypertherm machines, the 6585s, the kerf width is an estimate now, and it's on a separate page. But on the 45XP stuff, you're going to find an estimated kerf width with each of the lines in your cut chart. So when I zoom in, you can see that the kerf width that it tells us that we're going to have cutting 14 gauge with fine cuts is 27 thousandths. That's an estimate. So if I draw a dimension part and I use that, well, Ron, if it's a pitman arm, you're going to either need to drill some holes in it or cut a hole. What's your plan for the holes? I'll show you how to put the holes where they belong real quick. So to set your kerf, I'll come back to that. So to set my kerf, my method for thin material, I don't do this with 1/2-inch plate. I actually cut that's big enough kerf with 1/2-inch plate. I can cut a line and use a caliper and measure the actual kerf and get pretty good. But what I do is the very first thing, I go into my offset convert tab and I set my kerf to 0. And what that's going to do is when you create a cut path with a 0 kerf, the cut path is directly on top of the line you drew with no offset whatsoever. So let me draw a square, and let me show you a quick way to draw a square. Most people that I know either draw a square and then try to scale it to get it perfectly square, because we don't have a square tool in the menu of Design Edge, but there really is one there. Or they draw, you can use the draw rectangle tool and snap it orthogonal, or you can use the rectangle tool, enter coordinates and get a square. So I could use W to make the rectangle and then type in the at 2, 2 enter and draw that a 2-inch square, which is where I'm headed. I want to draw a 2-inch square to cut. But the fast way to do it is to push Y, which is your polygon tool. From here, I could draw a square, a pentagon, a hexagon, an octagon. It doesn't matter. A 20-sided circle, whatever, a decahedron, whatever you want to call it, whatever you want to make, you can draw. But that includes a square. So a square is a polygon with 4 sides. So I pushed Y, 4 enter, 2 for 2 inches enter, and there's my 2-inch square. So I'm going to now then use N for new cut path, convert to cut path, and I'm going to convert that to a cut path. And I'm going to cut it with the consumables, amperage in the material that I want to set my kerf for to make these dimensioned parts accurate. And so you can look and see if I turn that path on and off, you can see the cut path is directly on top of the line that I drew. And so let's say I cut it, and then I get my calipers, and I'm going to give you an on-screen representation here. Let's see. And so I get my caliper and I measure it, and it's 1.93. So however much short of 2 inches that square actually measures, that will tell me what the kerf is, the entire kerf, because half of it came off one side, half of it came off the other. So 2 minus 1.93, which is what my caliper said when I measured the physical square that I just cut, tells me that my kerf is 0.07. And so now I can go in and set my kerf to 0.07. And then when I make a new cut path, for my square. Then it will offset half the distance, or 35, but it'll offset half the distance so that my actual square that I cut winds up being a true 2 inches. Because as you can look over here and see, that the show wide cut path shows you that I'm actually cutting in on top of where I was supposed to cut. So that's how I was able to measure that. If I were to measure that, I could kind of get an approximation here just to show you that that's what it's going to measure, and that's what it offsets. So to get true dimension parts, you must draw it accurately and have your curve set accurate. And once you have that, you'll get the right dimensions. You do need to slow down on holes. Anytime you're cutting holes under 1/4 of an inch, for sure, I recommend that you do a, what you call it? Sorry, lost my train of thought. Not that that takes a lot these days. Let's see. Easy way to radius the lead-ins. Well, yeah, you can radius a lead-in manually, but my question would be why? I have done in the sheet metal business when I did heating and air conditioning. We did a lot of holes, circles, holes, and we used a radius lead-in because that's what the nesting program did. Don't do it. Don't use that program much anymore. Don't notice any decrease in quality on the holes. So I know that it's been recommended by some people at Hypertherm that a 90-degree lead-in it produces as good or similar results. It'd certainly be worth trying to see if it solved your problem. But let's see. To radius a lead-in, you would essentially just get rid of that. And I know you'd probably really be doing it. Let me do it this way. So you'd probably really be doing it in a hole. And so I would K break it at that end node point. Get a little closer and get to the right one. And then all I would do is do a Z bulge, like I was saying earlier, from that E endpoint and join it like that. And once you join it, then you can see where your pierce point is. Now, you bring up the divot, and that's something certainly worth talking about. Because if you look, I have a gap at the end of my loop set at 0.01. And that's because as the torch comes back around, when it gets to the spot where it started into that path, there's no metal under the torch. So if we don't stop a little early, then the torch is the arc is going to spread out and look for material to cut. So to eliminate the divot, it's important to know whether it's happening at the beginning or at the end of the path. So what I would do is I would start this cut, and then I would stop it somewhere over here and look at that and see if I can tell if maybe it has gone out past where it should because of acceleration, or if it's really creating the divot at the end and not the beginning. Because a lot of times we try to fix these divot problems with lead-ins when in fact it's happening at the end of the cut when it comes back around. So make sure that you're fixing a problem at the right end of things, because you can work on that lead-in for a long time only to find out that it's continuing to be there because it's happening at the end. Some settings to check for that if you have advanced machine control is make sure you don't have a positive number in the time to continue cutting at the end of the path, because that will just make the divot worse. As I say, the arc is going to fan out trying to find some material to cut there at the end. And then the other, of course, is what I said is the offset convert. That's the gap at the end of the loop. And you're going to want to be sure to have some positive number in there up until you get to about half the kerf. You know, you're going to have a deal. So if my kerf's 0.07, I could be 0.02 or 0.03 when I'm trying. And if you go too far, it's just going to leave a little tab and a tick sticking out instead of a divot in. But you can at least play with that setting and see if you can get rid of the divot that way too. But your radius lead-ins, unfortunately, is not a setting that you can change. You would just have to manually draw that in. So let's see. Oh, how to insert a hole. That's one of my favorites. So we go back to that center of mass measurement tool. So let me see if I can find us a fun one. So here's a sign that I drew for a customer. And so if I'm going to hang this on the wall, if I don't allow any spot to hang it and my customer puts themselves a nail right in here in the P, you know, chances are it's not going to hang level. So they're going to have two nails. So Tim wants to know how best to place a nail hole or a place made for hanging. So the way to do that is to select your entire piece and push F8. And that's going to give you the measurement of the close paths. But once you hit escape or close, you're going to see that it leaves behind this little red spot. And so that spot is the center of mass, both vertically and horizontally. So to make it hang level, all we have to do is put a hole somewhere on the top side above that red spot in our piece. So if I draw an L line, and here again, I've got to use a snap to get accurate. So I'm going to use S for a spot snap right here. And since there's only one spot, it doesn't matter where I click on the screen, it jumps to that red spot. So now I have a line anchored at the center mass, and I push O for orthogonal snap, and then I go straight above it, and I click to draw that line, and right click to stop. So now anywhere along that line, I can put a nail hole. If I want to put a hole, let's see, Q.125 enter for an 1/8 inch hole. If I want to put a hole here on that line, I would use an H on the path snap, and I would just put it right there. And so now when you hang this on the wall, it's going to hang on that nail, but since it's the center of mass, it's going to hang level. If I didn't want a hole there, and I needed it up here above my piece, I could always just draw a spot to put it. So I can do an H on the path snap, and I can put it right there, put my circle in the center, C center snap of that one, and I can delete this stuff out and use the X trim. So I could put it up above. So as long as it's anywhere on the line, the center of mass line above the middle, then you'll be fine. And as long as you don't do any major changes when you add your little piece, you know, you won't make any drastic changes. But that works for, see, I've got a file that's got a hanger on it. That I drew. Oop, that's the laser one. It doesn't have any bridges at all. And so I needed somewhere to hang that piece. And what I did is add that little piece there. But when you select it all and push F8 for measure, then I get this spot out in the middle of nowhere, and I do a line from the S spot, O orthogonal, and you can see that that goes through my circle. So I have one of those hanging up, and I promise you it hangs just perfect. Let's see. All right, we've been at this an hour. Anybody else have any more questions? Anything they've run into that didn't work the way they wanted to? Something they wish that it would do that it isn't doing for you? I will briefly touch on acceleration. Sure. One quick note about acceleration, and if we don't have any more questions, we'll wrap it up in a minute. If we have some more, I will be happy to stay and talk about what you've got going. Acceleration, when you put a number in that box, the measurement that you are changing is huge. It's huge because 1g is the acceleration of gravity, which is what, 8.33 meters per second. So that's a big number. So that's why we have fractions of numbers in our acceleration box. So if you change from an acceleration of 0.2 to 0.1 or 0.2 to 0.5, that's a lot. I mean, you have changed dramatically your acceleration. So if you have advanced machine control and you want better cuts on your thinner material, my advice and my rule of thumb is anytime your cut speed is 150 inches or more a minute, put your acceleration at 0.05, okay? And if you need to change that, change it in hundredths, not tenths, and certainly not whole numbers. So if I adjust my acceleration, I'll go 0.06, 0.07 to go faster, or 0.04, 0.03, even 0.02 on finer artwork where I need to get the motion slowed down so that it isn't jerking in and out of the corners on thinner material cuts. So be careful. I've seen someone accidentally put like 0.15 in there, and I think might even more than that, and they wound up with, I mean, it's unrecognizable. Their cuts were terrible. For C, small circles, on what thickness would be my question, because all air plasma is going to have some bevel. 3% is pretty tolerable. I get really good cuts on 1/2 inch and pretty good on 3/4. But the bevel is more pronounced on very, very thin material in my experience. So when I'm cutting 12 gauge 3/16, there's a noticeable bevel. So the best way to reduce bevel is to get your torque height accurate and consistent. Okay, for quarter, you should be able to get really very good bevel results, at about 3%. For 1/4 inch, I use slower on holes under 1 inch because the cut speed's down at 90 on mine, cutting at 45 amps. The other thing I'll say is, especially if you're using a hypertherm cutter, you always want to choose the lowest amperage consumables and settings that will cut the material that you're working with. So yes, you can cut 1/4 inch with 65 amps. You will get a lot better cut quality if you put it down at 45 amps and use a 45 amp nozzle. They're designed for that arc intensity and that voltage to be matched up. I know there's a lot of numbers on your machine. It's digital, probably like mine in between. You can set it at 47 and 52 and 39, but whatever's printed on the side of the nozzle is what it's engineered to work at. Put it on that. So if you're cutting 1/4 inch, 45 amps, 45 amp nozzle, slow down on circles under 1 inch. And I would set I'd set my acceleration probably to 0.08. And that's going to, I don't ever get my cutting motion acceleration up above 0.1 personally. I would rather deal with a little bit of low-speed dross that comes off pretty easily and still have a good cut quality versus some high-speed dross and some bad cuts from just trying to shove it fast. Speed's marvelous, but unless you're in a tremendously high production environment, I care a lot more about cut quality and how much dross has to be cleaned off. And if I can drop it on the floor and get the dross off, I'm happy with it. So about the smooth tool, that is probably my third or fourth most used tool compared to, right behind the bulge and the trim. But the trick with smooth is you have a margin. And so that means that you have to tell it the margin that it is to look at and think about whether or not it's a straight line or a circle. So yeah, if I select, I'm going to get a piece of this, not all of it, maybe, hopefully. Okay. So if I select this bed, if I smooth that to a 0.05 margin, it's all a mess. Sure thing. Thanks for stopping by. I hope it helped. If the margin that I just used, a 0.05, is way too large, okay, because it took pieces in here that were, this is very small for one thing, but it took lines that are supposed to be still arcs and made them into circles because the margin was so large that it has terribly unintended consequences. So if I look at this, when I smooth something like this, as small as it is, your margin is going to depend on how big the piece you're working on it is. The smaller it is, the smaller margin you need. If I'm doing something to reduce nodes and clean up a drawing, my margin is going to be 0.001, 0.002, 0.003, probably not more than 5 thousandths. So let me just show you a smooth to a margin of 0.005 on this piece. Hardly any visible difference, but let me look at what it did. So I drew this for my laser with a much higher arc resolution than I currently have set. And so if you can look here, there's 3,234 nodes in that little bitty piece. And that's because that's the precision that I have it drawn at. But if I smooth that for plasma cutting at a 0.002 margin and hit enter, I now have 2,000 nodes. So I went from 3,200 nodes to 2,100 nodes. So that really cleaned up the drawing. It's going to have a lot better time making a cut path for the conversion. It's harder for it to offset when there's so many nodes. It takes a lot of computer power and it's unnecessary for plasma. So hopefully that helps. I mean, again, the smooth tool can be used for a few different things. Probably the most common thing I use it for is to just reduce and clean up nodes. Now, if you draw something in Corel, or if you import a trace, or if you get a file off Plasma Spider, chances are it's got a zillion nodes. Maybe some stuff overlaps. Maybe it's a mess. I don't know. But you're going to be needing to clean that up. So let me pull in another file real quick. So you do use the smooth to pull out those extra nodes and to clean that up. But the very last step before you convert to a cut path would be to use the smooth tool. That's going to prepare that for the offset and make yourself a lot better chance of success at having a good, clean cut path. So smooth it out. If you have a smooth path, you can get smooth cuts. To adjust a file that you're going to cut from big to small. So this is drawn at 18 inches. I think. And if they wanted a keychain, then I would have to scale that down. And the problem is, for one, you have to look and see if it's even can be cut by plasma. So I do my Q 0.035, let's say, is what I'm saying my torch kerf is, and look where it can fit. And so that's not terrible. I can make that happen. I don't know that there's an easy way because you just scale the whole thing. But you do need to come in. I use my dimension tool to look. So that one's 0.2, that's fine. That's 90 thousandths. So that little arrow is going to have a hard time. So I would be concerned about that burning up and falling off. So you just have to look at the different aspects of your drawing and come up with, you know, a way to fix it and make it doable. For me, I would come in here and draw myself a line down the center of that, knowing that I want to leave at least 0.15 in there, and I would offset, over offset 0.15, but I'm going to go each side of that, so /2. So I'm going to have it do the math for me in the command line. Offset 0.15 divided by 2, enter, and then I will hold control and click on one side of it. I will let off control and click on the other side. And so you can see what that did for me is now I've offset so that I will have 0.15 in there, and then I can X trim my bits and pieces out. And I can decide what I want to do when I come down here. And I mean, I could leave that little nub on there, or I could break it at these end node points. Just trim those out, and I'll show you. So I can't extend that because there's nothing for it to hit. So I'm going to hold down control to force it, and that's going to just send it over to the edge of the screen. Same way on this side, hold control, J for join. So I mean, other than going in and looking where your torch will fit, I can do the same thing on the inside corners to check and see. I can do a fillet, which is F, and tell it the radius to be my kerf divided by 2, since it's the radius. So 0.035 is what I have said my kerf is, /2, enter. And then if I click on that corner, any of those hard inside corners, that will show you what it's actually going to look like where that torch will fit. So it's going to be a little different, but none of that looks to be a problem to me. So it's just a matter of looking to see on each individual file what detail can stay and what won't stay. Like that race car example I had earlier, you know, there's no way we could have gotten all those zigzags in there. We just had to kind of draw some in that visually represented the detail that we wanted to show. Well, I don't speak Spanish. Pretty sure I don't have any communist propaganda either. So, okay. Well, let's see. Did I miss anything? How do you fix a busted control box cheap? Isn't your machine still under warranty? I mean, it's like new. It's not 3 years, 36,000 miles. It's just 3 years. For us poor people, we have to keep a spare on the shelf because out here in the country, when it breaks down, it just breaks down. Let's see. We've either answered your questions. Oh, yeah. Well, again, you have to have a spare. You have to buy a used table. Mm-hmm. Yeah. Right. Yeah. Okay. That's what this is for. When it quits, you just take this out to the table and put it on there. And then you send your other one in to be fixed. What do I recommend for 14 gauge cut speeds? Yes, I do have a 5x10 spare table that's hanging in the tree in my front yard. Let's see. So, help me remember, Tim, which plasma cutter do you have? Because that's where all of my recommendations are going to come from. Yeah, maybe in your other settings. I mean, I assume you're still following the instructions that I preach and preach and preach and put at the corner of my mouse pad, which is, set those four main things from your manual. If you have a hypertherm, then you're going to be at you're going to be at book specs because, okay, 45 XP, well, that's what I've got open right here. So let's look at it. So the first thing you do to get good cuts is you use the lowest amperage consumable. All right, thanks, Chris. We'll see you later. Hope you make it also. Okay, let me turn this back on for you. You don't want to look at me anyway. Okay, so this is a 45 XP right out of the manual. Anything 10 gauge and under, I personally use this fine cut consumable stack right here. And I think that's what you're using. But it is very important. Fine cuts are very particular about height control. They need you to maintain it accurately and consistently. That 220947, is that the... Yeah, don't use that. I don't know why in the hell they put that in here. I normally preach that the hypertherm manual is the Bible, but don't do that. Don't ever buy that 220947 swirl ring. Okay, you want to use the 220857, which is the same one that you use for all the other 45 amp processes. So please ignore that. Maybe I can be scolded by the hypertherm people later, but I can tell you I have seen it cause problems, and there's really no need to have problems. So 14 gauge, see if I can get this thing to do what I want it to do, is, oh, that's nice. There we go. So 14 gauge, right out of the book, hypertherm says use 45 amps, fine cuts, 0.15 pierce, 0.06 for a cut height, 200 inches a minute with a 0.4 second pierce delay. Now, let's really go back to and drill into your machine control and height control settings. So if you've got that at 200, and I think that was 0.4, and you're at 0.15 and 0.06. So I must admit that on my 65, I cut with the fine cut tips. When I cut a lot of 14 gauge, I do it 190 inches a minute. In my book, fine cuts are recommended at 220. So maybe change it to 190, because what happens to me sometimes is as it comes out of a corner and takes off, I don't know if maybe the power supply can't quite keep up with the acceleration that I have it set at, but I'll have a spot. It's not that it doesn't cut all the way through, but it's going so fast it blows the dross back up and it sticks. And so I have to break that piece out and wind up with kind of an unclean cut for about an inch or two. So I'm going to say put that on 190 for 14 gauge. And for my corner acceleration, I'm going to put that at 0.02 or 0.03 to start with. And I'm going to do my slower on circles and curves at 2 inches so that it has opportunity to slow down in more places. And then, of course, the height control is going to be directly from the book, unless they're brand new consumables. And so here's the only other caveat for fine cuts and hypertherm and height control. When you have a brand new set of fine cut consumables in, change your cut height up to 0.07 and see if that does improve. As the consumables wear, as you get a few hundred pierces on them, you can put it back at 0.06. Anytime you make a change there, be sure to do the auto zero with a straight line. Get your straight line set up, check your auto zero boxes, and re-zero it. That way you'll have the best chance of success of having that correct cut height maintained. If you still aren't getting good cuts, then I would recommend drawing a nice long line, maybe 10 or 12 inches, after you have zeroed your arc voltage shift with your consumables in. And I would start that cut, but I would use the stop button on the controller to stop it and then physically measure that. And you can do that with any set of consumables anytime you're having cut quality issues and you think it might be related to height. Stop that, go in there and measure it and see where it's at. And if you measure it, you need to be cutting at 0.06 and physically 0.06. When I tell you to put in 0.07 cut height, that's really going to result in a closer to 0.06 height. So if you measure it and you're cutting at 0.08 and you need to be cutting at 0.06, you can make a physical change to this arc voltage shift. You can come back in here and open it, and you can adjust that. That is, if you look, it shows you it's in inches. So if my arc voltage shift is 1.3, let's say, after it's automatically calibrated, and I need to lower my cut by 20 thousandths, then I would subtract that from that. And so this would be, I could change it to physically 1.28, tell it okay, and then cut that same test line again and measure it again. So check and see where your cut height actually is if you're still getting bad quality with that. But do your 14 gauge 190 inches and try these acceleration settings and see if that doesn't help you. I know we've talked about the acceleration in the past, but I think you'll have better luck with those. Thanks, Jay. I have a lot of fun with this, and I can certainly do that. I don't know if I've got your email or not, but I've got you on Messenger, so I'll hook up with you afterwards. But let's see. Well, we're about to wrap it up unless somebody's got anything else. I allowed until 4 at the latest, and I've got 30 more minutes to waste, or I can kick it off early and take a nap before the kids get home from school. So if you guys have any other questions about settings or design edge or drawing, or even about the upcoming classes that we've got, this is not an advertisement for that. This is something fun that I like to do, but it is a small window into the 3 days that we get to spend together when we have training, and that kind of gives you a glimpse of what we can do in class one-on-one with me right there, instead of having to put up with my my Hooterville Green Acres internet connection. So if nobody else has any questions, though, I will get it wrapped up. We will do this again sometime. So if our time together sparked some more questions than it did answers, or answered some and causes you to have some fun and run into some more, well, just let me know. You can get in touch with us on our Facebook page or comment on this YouTube. So yes, definitely. Yeah. Yes. If you have as far as the classes go, if you have an extra seat for Design Edge, I strongly recommend you bring it. I have a few extras on laptops that I bring, but they're not, they go pretty quick for folks that that need them, and so they're first come, first serve. So a few people have already even arranged them for future classes, so they can go quick. If you have one, and I do recommend you have one anyway, it works so much better to be able to design in your office, in your house, in your wherever, than out there tied to the table. So I will, Tim, but I've got a 5-year-old and a 17-year-old, and so when the 5-year-old's home on the weekend, it makes for some interesting interruptions. We would not have had a nearly as productive piece. So I have to pick a time when she's got something to do and I don't have to fight her. But I thank you all for stopping by, and look forward to seeing you again here and maybe in a class. Thanks.